Welcome back. As you know by now, power electronic converters are always installed between photovoltaic panels and the alternating current or AC distribution network. Power electronic converters are used to adapt the power output of the electrical sources to the needs of the load. In the upcoming 2 video lectures, you will learn about the important role of power electronics in connecting the various components in a PV system. You will get acquainted with basic concepts and elements that will allow you to understand the principles of how a power converter works. The learning objective of this video lecture is to understand the principles of direct current, alternating current, single and three-phase, different type of power conversions, AC-DC, DC-AC, DC-DC and AC-AC, and the working principle of the AC-DC rectifier. First, let's have a short recap of the various current systems that are being used. Direct current, abbreviated as DC, can be defined as an electric current that flows only in one direction. Direct current may flow through a conductor such as a wire, but can also flow through semiconductors, insulators, or even through a vacuum as in electron beam or ion beams. The electric power is constant in time. Alternating current, abbreviated as AC, is defined as a periodic electric current that reverses direction. It can have different shapes. In traditional power system, it has a sinusoidal shape. Because the voltage of a single-phase system reaches a peak value twice in each cycle, the instantaneous power is not constant. Generally, the phase in electricity is the current or the voltage among an existing wire as well as a neutral cable. Single-phase systems have 2 wires. Standard frequencies of a single-phase power system are either 50 or 60 Hz. Here you see a single-phase electric power, which is the distribution of the alternating current electric power using a system in which all the voltages of the supply vary in unison. Single-phase distribution is used when loads are mostly lighting and heating with few large electric motors. In 3-phase power, the voltages on each wire is 120 degrees phase shifted relatively to each other of the wires. A 3-wire, 3-phase circuit is usually more economical than an equivalent 2-wire single-phase circuit at the same line to the ground voltage because it uses less conductor material to transmit a given amount of electrical power. A 3-phase includes 3 wires and a neutral wire. 3-phase power is mainly used directly to power large induction motors, other electric motors and other heavy loads. Small loads often use only a 2-wire single-phase system. Power electronic converters allow us to process and control the flow of electric energy. By means of a power converter, it's possible, for example, to convert alternating current into direct current. Based on the input and the output waveforms, power converters can be classified into 4 types. AC to DC, also known as rectifiers. DC to AC, also known as inverters. DC to DC and AC to AC. Power converters are capable of adapting the voltage and frequency of the power supply into the voltage and frequency required by the load. We will first, in a simplified electrical engineering picture, explain the principle of the rectifier, the conversion from AC to DC. This is done through power semiconductor devices, such as the diodes, among others. As a reminder, a diode is a semiconductor device that allows a current to flow in one direction only from the anode to the cathode. In the figure, you can see the representation of an ideal diode. When the voltage at the input side is higher than the voltage at the output side, a current will flow in the direction of the output. Let's see in this example. If the voltage at point A is higher than at point B, then the current will flow from A to B. If a diode is placed in between points A and B, with the anode facing the input side A and the cathode facing the output side, the diode will allow the flow of current and it will flow as shown. Early in this MOOC program, we have referred to this bias condition as forward bias. If a current tries to flow in the opposite direction because the voltage at point B is higher than point A, the diode will block the current flow. Earlier in this MOOC program, we have referred to this bias condition as reversed bias. Let's see now how this information about the operation of the diode will help us to understand how a power converter works. Let's consider this circuit containing 4 diodes. On the right, the alternating input voltage in time is given. In time periods 1 and 2, the voltage is positive, and in time periods 2 and 4, it's negative. When the voltage signal is positive, which corresponds to the time periods 1 and 3, diodes D1 and diode D3 in forward bias will conduct, and diodes D2 and D4, which are in reverse bias, will block the current because of the positive direction of the current. Notice that the direction of the arrow in both the input and the output voltage goes from the node highlighted in blue, the negative side, to the node highlighted in red, positive side. This means that both voltages are the same in magnitude and direction, therefore the output voltage is the same as the input voltage in the time periods 1 and 3 as shown in the figure. On the other hand, when the voltage signal is negative, which corresponds to time periods 2 and 4, diodes D2 and D4 are in forward bias and will conduct, and diodes D1 and D3 are in reverse bias and will block the current. Notice that the direction of the arrows are different in this case. The direction of the input arrow goes from the node highlighted in red to the node highlighted in blue, whereas the direction of the output arrow goes from the node highlighted in blue to the node highlighted in red. This means that the output voltage has the same magnitude but opposite sign to that of the input voltage. As you can recognize, the converted signal is now positive in all time periods, and if an average line is drawn, you can see that it has a constant positive value. It is therefore said that the voltage is rectified. The discussed simple circuit here could be the circuit inside a power converter. In this case, due to its operation from AC to DC, the power converter can also be called a rectifier. A rectifier is necessary, for example, when connecting a laptop which operates in DC to the AC supply socket. The power coming from the socket is AC and is then rectified to DC as required by the load. Today, we analyzed a very simple topology consisting of only 4 diodes. However, more complex topologies are used to process the input signal into a more constant output DC voltage or into a different DC averaged value. Be aware that the topology used today is only a simple example. In summary, we have discussed DC currents and single and three-phase AC currents. We have discussed the classification of different types of power converters. You were introduced to a simplified electrical circuit that can represent an AC to DC converter based on diodes. In the next video, we will continue the introduction to different power converters. We will discuss the DC-AC inverters and the DC-DC converters. So, see you in the next video.